So this is the practice of VSEPR. Okay. Now let me ask from some of you. Let me start from Felicia. Felicia, Felicia, what is the shape? Oh, let me do not start with the shape. If start with shape, it's getting confused. What is the number of electron pairs in beryllium chloride?
4 lone pairs.
How many lone pairs?
I think 4.
Four. Four lone pairs. How do you count four lone pairs?
Drawing the dot and cross diagram.
Dot and cross diagram. What is the atom that is located in the central? In the center?
Beryllium.
Beryllium. How many lone pairs are there in beryllium?
Only 2.
No, those so the lone pairs, two lone pairs. Let me draw on the using annotation here. Wait, let me choose the black pencil, and then this one beryllium chlorides. This one you are drawing on your paper. Am I right? This one there is a Cl, and then Cl, Cl, and then there is like this. Am I right? And then there is this one, and then this one. How many lone pairs are there in beryllium?
0.
Yeah,
None.
none. How many bone pairs?
2.
Please look at the textbook or look at the PPT that I give, that I attach on the Google Classroom. What is the bone angle?
180 linear.
Yeah?
180 degrees linear.
Yes. And
Shape.
the shape linear. Is it difficult, Felicia?
A bit complicated. Just a bit.
A bit. Okay. Now let me ask to Ariela. Ariela. Hello, Ariela.
Yes, teacher.
Yeah. For boron fluoride, number 2. For boron fluoride. This one, yes, boron fluoride. How many lone pairs?
0.
0. How many bone pairs?
3 bond pairs.
3 bone pair. So, what is the shape?
Trigonal planar.
Trigonal planar. It's not difficult, right?
Not really.
because you have
I
not
don't know, teacher.
seen the difficult one. You just I just give the easiest because work example has to be the easiest. Am I right?
Yeah.
And then number 3. Number 3. Let me ask to Patrix. Patrix.
Yes, teacher.
Yeah. For number 4, CH4. How many bone pairs are there?
There's 0. I mean, there's 4.
Yeah, 4 bone pairs. And then how many lone pairs?
0.
0. So what is the shape? What is the bone angle?
The bone angle is 109.5.
Yes. And then the shape?
Tetrahedral.
Tetrahedral. Right. It's not difficult, right?
Yes.
Yeah. It's easy, not difficult. Do not make it complicated. And then now next four. Number 4, PCL3. PCL3, I do not remember your names quite well. I remember only some. So let me ask from Natasha. Hello, Natasha.
Yes, teacher.
Yeah, Natasha, could you help us to tell how many bone pairs are there in phosphorus 3 chloride?
There are 3 bond pairs.
3 bone pairs. Okay. How many lone pairs are there in phosphorus 3 chloride?
1 lone pair.
1 lone pair. So, what is the bond angle?
107.
100?
107.
Yes. So, what is the shape?
Trigonal pyramidal.
Yeah. So, the questions will be like this. Okay. There is a molecule or ions. The ion is not monoatomic ion, but would be polyatomic ion. Example, the polyatomic ion the polyatomic ion that could be the question is asking about this one, NH4 positive. Let me ask to T cell. Hello, T cell.
Yes, teacher.
What is the number of bone pairs are there in ammonium ion?
4.
4. How many lone pairs?
1.
1.
Eh,
Are you sure?
wait. 0.
Have you drawn the dot and cross diagram?
Wait. There's 1 missing, teacher.
Yeah. I'm not asking how many missing. I'm asking how many lone pairs are there.
If it's positive ion, what does that mean, teacher?
Means
If
that
there's
it has lost its electron.
so 0, teacher.
0. 0. That means what is the bond angle?
109.5
What is the shape?
tetrahedral.
Yeah, that is the example. Okay, so all students, this cell already could answer. So this is the possible question of the polyatomic ion for the VSEPR. Of course, there are still some. Of course, there is still some. Like example, uh, phosphate. Phosphate PO3 minus 4 for this phosphate. Let me ask to Bhavya. Hello, Bhavya.
Yes, teacher.
Yeah. Bhavya, could you help us to tell how many bone pairs are there in
Four.
for phosphate?
Four.
4. Are you sure? Are you sure there are 4 bone pairs?
Yes, teacher.
Is it not more than 4?
No.
Have you drawn the dot and cross diagram?
Teacher, I draw for PO4.
Yeah, it is phosphate. So phosphate, in order to have 4 phosphate, no, it doesn't have 4. It has 5 bone pairs. It has 5 bone pairs. But there is 1. So if I draw here P, draw dot and cross already, and then there is O here, and then there is O over here, and then there is O here, and then this one minus, and then this one minus. This is the structure of phosphate. How many bone pairs? 5. But it seems that it has 4. How come? Because of this double bond. This double bond makes uh, the bond looks like one bone pair. Because the reason the double bond occurs due to overlapping of s orbital and p orbital of the same atoms. So this double bond looks like 1. So if it has 4, as if it has 4 bond pairs, the shape, what is the bond angle, Bhavya?
If 5.
No. How many bond pairs are there?
If there are 5 bond pairs, then it is 90 and 120 degrees.
No, you did not listen, Bhavya. It has 5 bond pairs. It has 5 bond pairs, but these 2 pairs, it looks that it has only 1. Why? Because this double bond occurs due to overlapping of s orbital and p orbital of the same atoms. So we can consider this double bond as 1. So consider as 1 bond. So there are total 1, 2, 3, 4. So how many? So what is the bond angle, Bavia?
109.5
What is the shape?
tetrahedron.
So this one, this one, ammonium and phosphate, they have the same bond angle and they have the same shape. Okay, so there is the possible question of the polyatomic ion, which is become VSEPR. Okay, now
Sir,
let's yes,
did you say NH4 plus is having four bond pair, right?
yeah, it has 4 bond.
But I thought plus means losing electron from the hydrogen.
Yeah,
Isn't the if it's in iron, so there's a plus sign. Is it
yeah.
not that the hydrogen loses the electron?
Iron has shape also. Iron has shape of the iron. So it's not always molecule that has shape. Iron could have shape also.
I mean, like I thought H plus is the hydrogen lose its electron, so there's zero electron.
Oh no. The plus is the electron of the nitrogen, which is the plus. The plus this one is the belongs to the whole group. This is ammonium is a whole group. Which electron has it gone? It belongs to a group. So it is not longer individual. Okay. So we cannot say that, oh, it is lost from the nitrogen or lost from the hydrogen. No, it is unity. Also similar to phosphate. The 3 minus. 3 minus for who? For which atom? It is for the ion, because phosphate is a unity. We should not separate it.
How do we know which electrons are the one being removed?
Which electron?
Being removed. How do we know which one is it?
Which ion is that? It must be
Um,
polyatomic ion. It must be polyatomic ion. Okay. Now let's continue. Don't worry, I'll give more exercise on this. I know you confused. And then number 5. Number 5, let me ask from number 5, let me ask from Matthew. From Matthew. Hello, Matthew.
Yes, teacher.
Yeah, Matthew, number 5, in hydrogen sulfide. Could you tell us how many bond pairs are there?
Two,
How many lone pairs are there?
two.
So, what is the shape?
Uh, pen V shape.
Yes. What is the bond angle?
104.5.
Yeah. And then in SnCl2, let me ask from Nathan V. Hello, Nathan V.
Salutations, sir.
Yeah. So what is the shape of the this one?
Which one, sir?
SnCl2.
SNCl2.
Yes.
Uh,
How
we
many
will have like
pairs?
wait. Let me search SN. Wait, SN which? Wait. and elements. Tin is from the table.
Sn is in group 4. Tin.
Group 4. Okay, group 4. So, wait. Sn is group 4, so we have like 4 currency.
So how many bond pairs?
We will have 2 bond pairs.
2 bond pairs. How many lone pairs?
Lone pairs, 1.
So what is the bond angle?
The bond angle will be around, wait, let me draw it first. Will be around, let's say, I think 108 degrees.
What is the shape?
The shape is a triangle.
Triangle. Is the shape triangle? Let me find in VSEPR. Okay, in VSEPR, 2 bond pair, it is 119 bent
Oh,
V shape.
the shape.
Yes.
Okay, close, but not so close. Okay.
Yeah. Okay. Next. Number 7 until number 12. Number 7. In carbon dioxide. Let me ask to Timothy. Hello, Timothy.
Hi, Chair.
Yeah, good morning. What is the number of bond pairs are there in carbon dioxide?
Mm,
How many bond pairs?
um, I think it's two
Two.
lone pairs.
Two. How many lone pairs?
Um, Four
The bond pair. How many bond pairs are there in carbon dioxide?
lone pairs. Four.
4. Correct.
Yeah,
How many lone pairs are there?
lone pairs. Lone pairs. Zero.
0. So what is the shape?
The shape is
Yes.
yes, like that.
Yes.
Um, Tetrahedral.
Tetrahedral. No, it is not. It is not tetrahedral. Can anyone tell what is the shape of this molecule? Maybe Ariella? Oh, yes, Ariella?
Linear, teacher?
Yeah?
Linear?
Yes.
Is it linear?
Why is it linear, Ariella?
Because there are 4 bond pairs, but 2 of them are double bond.
Yes. 4 bond pairs, but 2 double bonds. And we know double bond is because overlapping of s and p orbitals of the same atoms. So as if they have 2 bond pairs with 0 lone pair. So in order to tell the shape and bond angle, we are not able to tell directly how many bond pairs. 4. How many lone pairs? 0. Oh, it must be tetrahedral. We cannot say like that directly. We have to draw. Okay, we have to draw dot and cross diagram, and then we can determine whether it has linear or bent or whatever the shape is, and also whatever the angle. Okay, now yes.
But if example question asks how many bond pairs does CO2 have, do we answer it as 4 bond pair or 2 bond pair?
This one, it has 4 bond pairs. It has 4 bond pairs. If we say it has 2 bond pairs, not correct. It has 4 bond pairs, but the 4 bond pairs are consisting of 2 double bonds. Why is it like that? Because a pair is must consist of 1x 1 cross 1 dot. This is called a pair. And then in this one, how many dot and cross? There are around 4 pairs. There are 4 pairs. So we cannot say it has 2 pairs. But so we have to see completely. We cannot see only accept partially. If we accept partially, then it is 4 bond pairs. We have to think completely. Completely, it means that, oh, we see this one. It has 4 bond pairs. And then the fact is, these 4 bond pairs are divided into 2 double bonds. In one double bond, there are 2 bond pairs. So these 2 bond pairs occurring because of the overlapping of the same s and p orbital of the same atoms. So because they are overlapping of the same atoms, we can consider it as 1. Okay, so do not directly 4 bond pairs equals to 2 bond pairs. Do not directly take that conclusion. You have to see what is the explanation in the middle. Okay, so do not directly draw the conclusion 4 bond pairs equals to 2 bond pairs. No, you have to see the structure, the dot and cross diagrams.
Okay, thank you, teacher.
Okay, so never directly take the shape, don't directly tell the shape or bond angle directly from how many bond pairs, how many lone pairs. You have to draw it first. Okay, now with SO2, let me ask oh, there is information from WebEx that our meeting will end around 5 minutes. I think it will be enough. So SO2 based on the structure, so S here, S has 6 electrons, SO2, like this. So SO2, and then it has 1 lone pair. Because sulfur has 6 electrons around the outermost shell. So what is the shape of SO2? It is bent, just like SnCl2, bent with angle 119 degrees, V shape. And then how about SO3? SO3 S is like this. SO3. SO3 is this one. So 3 bond pairs and 0 lone pairs. It has trigonal planar shape 120 degrees. And then SF6. SF6 yesterday is the famous example. This one F around with 6 fluorine. So with 6 fluorine, F, with F, and then there are 6 fluorine here. So 6 fluorine, and then from here sign like this. So what is the bond angle? It is, the shape is must be a octahedral with 90 degrees. And then XE F4, yesterday already give as an example. XE F4, the shape is square planar 90 square planar 90 degrees. And then the last PCl5, it is, the shape is trigonal bipyramidal. Okay, so I already discussed this one. We need to fast but not too slow. We need to be fast because the time will not be enough for us. There's 5 minutes left. So let me take attendance here. There is Ariella, Beatrix, Bavia, Brian, Sherry, Clarabella, Eric, Felicia, Hardy, Kimberly, Lawrence, Michelle, Nargis, Natasha, Nathan V, Timothy, Tisel, Vanessa, Vedika, and Sharon. Okay, so all of you are here already. So from this one, you have to draw dot and cross diagram. Okay, I will attach a homework on the Google Classroom for drawing this what is it, the dot and cross diagram. Okay, so I'll give the homework. Is there any question?
Nothing, sir.
Nothing. Okay, so maybe I will see you again on. Oh, of course, I will not see you again. I will discuss with you again tomorrow because we will not see in person. We will discuss again tomorrow with this VSEPR.